Okay, hey students in Quantum Lab Physics 340, welcome to week 3. So first thing I'd like to say is I hope you're all doing well. I hope the first 2 weeks of your quarter went well. I hope the first 2 weeks of Quantum Lab went well for you. Those in person, I hope you're managing dealing with the PPE and all these social distancing and things. The virtual labs, I think they're actually going okay. We're having some nice conversation. You're slacking me your plots. We're seeing in your code, and we're seeing sort of how some things work. And I think we're making progress. So I think things are going okay, all things considered, and I hope it is for you too on your end. Okay. So this week we have a new experiment come out with the speed of light. Okay, speed of light's always a fun one to try to measure. It's one of those maybe first constants you run across as you study physics. Fairly straightforward experiment this week. There's a few ways of measuring the speed of light indirectly. This one's fairly direct. You're going to have a box, a white box here that's going to send pulses of light down. And it's not a laser or anything like that, but it's going to send light down some straight path. The pulse is about 50 nanoseconds in width. It actually comes from an LED, believe it or not. And you just sort of let the pulse travel and travel and travel, and then at some point at the end of the travel, it will hit something called a retro mirror, a retro-reflecting mirror, which is going to send the pulse back. So you sort of have a throw distance or a path that the light went down and came back, and you're going to time how long it took light to make that traversal. And you know what the distance is because you can measure the distance between the box that emits the pulse of light and the mirror. Don't forget the factor of 2, and you can calculate the speed of light from that. There's some nice features about this box that I'm talking about. You'll see it's a white box. You'll see either in person yourself or you'll see it in the videos, is that when it's about to spit a pulse out, when the pulse is about to come out, it immediately sends a signal to the oscilloscope to trigger. Okay, so we always immediately know when a pulse is about to leave the aperture of this box. We're about to leave. Very important time mark for us. And then when the pulse goes out and comes back, the box also has a detector in it that immediately tells us when the pulse arrived back again from its travel distance. And so we're going to get 2 pulses on the oscilloscope. One is the T0 marker of the pulse leaving the box. The other one is when it returned, and then hopefully they'll be separated by some time that has a little bit to do with the travel distance that the light traveled. Okay, so hopefully you'll have that. So it's a fairly straightforward experiment, but just absolutely perfect for us in our study of error analysis and curve fitting and lines and all that sort of thing that we're doing, and error bars. Okay, so the error bars are going to be straightforward again this week. Error bars in the distance that you're measuring, what would you defend on court in terms of where that mirror is, and then error bars on the times that you'll read from the oscilloscope. Okay, so it's a nice experiment. What else do we have? If you're in my labs doing this writing that we're doing, we're going to leave the introductory section after 2 weeks of that. We're going to write the methods section. So the methods section is about how would I do the experiment you did if I was reading your work, and it includes a figure. So unfortunately, it's going to be another brutal week of writing, and there is some figure drawing there, which is also kind of challenging as well. But we just got to keep cranking through this stuff and get it going. So the methods is on tap for this week. Check my lecture videos and the online help to help yourself get going in there. Okay. Also, Dr. Rios and I were talking last week, and we're going to start giving you the choice, particularly on this speed of light one, about which type of analysis you'd like to do, either the curve fit or the standard deviation of the mean analysis. And so we'll see about that, how that goes, but there are 2 techniques you can arrive at your result with. And as far as the lecture goes, I don't have anything new for you this week. I think we had a lot in the first 2 weeks because we had to get you going on some data analysis so we can do these experiments. But at the moment, you have 2 ways of arriving at an experimental result and an uncertainty. The first way is, of course, the curve fitting, using the MATLAB fit command, which gives you that confidence range, ultimately in the 68% level, that you can wrap into an uncertainty. That's one way. But the fitter's a bit mysterious. I'm sure maybe you don't even know what goes on inside that fit function, so we have to keep that in mind. But the standard deviation of the mean analysis is very powerful and important for this too. That's what the lectures are about this week. Although we've heard it, introduced it, and even used it, I'm pausing this week in the lectures just to go over that standard deviation of the mean one more time, what it means, how it works, why it's so useful, all that sort of thing. So I think probably in my labs this week, we might just focus on not plotting and curve fitting at all this week. I think we're going to do a standard deviation of the mean plot. And that isn't anything really formal, but between Dr. Christensen over the years and Rios and I, recently we've sort of come up with a nice graph that we like to address standard deviation of the mean, and that's what I have described, at least in my PDF turn-in on Canvas from my lab, and Dr. Rios, of course, will give you very similar instructions for doing the same. So that's what we have for you this week, okay? Speed of light, standard deviation of the mean analysis. We're going to sort of get that a little bit understood and seen a bit more. And so you won't find anything too new in the lectures this week. And by the time you're reading this, of course, the next reading assignment, reading quiz should be posted, and all the lecture videos are all ready to go as well. Okay, everyone? So I'll see my group virtually in lab this week. Looking forward to it. Our conversations and our work again. If you're in Dr. Rios' lab, enjoy. Speed of Light's a fun one, and I hope you're having fun working in person, that sort of thing. And yeah, I'll see you on Slack. Take care, everyone, and have a nice week number 3. Okay, bye.